What if we could predict future not through guessing but through data? Every time Amazon recommends product, Netflix suggests movies or hospitals estimate patient recovery times, regression analysis is silently working behind the scene. It is one of the most powerful tools in data analytics and statistics, a bridge between understanding what happened and predicting what will happen next. Welcome back to Shital's Data Desk, your one-stop destination for simplifying data, analytics and visualization. In today's video, we will unpack one of the most fundamental yet fascinating tools in analytics, regression analysis. You will learn what it is, how it works, why it is widely used in businesses, and how it transforms raw data into actionable insights. Before we dive in, here's what we will cover in this video, step by step. What regression analysis is, understanding core idea behind predicting outcomes using data. Types of regression, from simple to multiple to non-linear, and when to use each. Real world applications, how companies and hospitals actually use regression to make smarter decisions. Key assumptions of regression, golden rules that make your model reliable. How to interpret regression output, making sense of coefficients, R square, and p values like pro. Why regression matters. Why it is one of the most used tools in businesses and data analytics today. Summary and what's next. A quick recap and glimpse into our next hands on session. So, what exactly is regression analysis? At its core, regression is statistical method that helps us understand relationship between variables and use that relationship to make predictions. Imagine you are running an online store. You might want to know, if I spend more on advertising, will my sales increase? Or in healthcare, does increasing dose of medicine shorten recovery time? Regression gives you mathematical way to answer such questions with evidence, not intuition. In regression, we typically deal with two types of variables. Dependent variable y means what we want to predict, and independent variable or variables x means factor or factors that might influence it. Goal is to find a line or curve that best represent how changes in x affects y. Once we know that relationship, we can predict what y will be for any given x. But not all relationships are same. Sometimes they are simple, sometimes more complex. Let's explore different types of regression. There are many variations of regression, but most analyses start with linear regression. Let's understand key types you will encounter in real world analytics. First, simple linear regression. This model studies relationship between just one independent variable and one dependent variable. It is easiest form of regression and it fits straight line through data. Simple linear model is expressed using following equation. Y equal to a plus bx plus epsilon, where y is dependent variable, x independent variable, a intercept, b slope, epsilon residual or error. Example, in e-commerce, we can use advertising spend to predict sales revenue. In healthcare, we might analyze how patient age affects recovery time. But real world is rarely that simple. Outcomes often depend on multiple factors. That's where multiple regression comes in. Second, multiple linear regression. Multiple linear regression analysis is essentially similar to simple linear model, with exception that multiple independent variables are used in this model. Mathematical representation of multiple linear regression is y equal to a plus bx1 plus cx2 plus dx3 and so on plus epsilon, where y is dependent variable, x1, x2, x3 independent variables, a intercept, b, c, d slopes, epsilon residual or error. Multiple linear regression follows same conditions as simple linear model. However, since there are several independent variables in multiple linear analysis, there is another mandatory condition for model. No multicollinearity among predictors. In simple term, your independent variables should not overlap or tell same story, because when predictors are too closely related, it becomes harder to identify which one truly drives outcome. Example, an e-commerce platform might use price, ad spend, and delivery speed together to predict sales. A business could analyze how training hours, motivation, and work experience affect performance. Third, nonlinear regression. Sometimes data doesn't follow straight line at all. It bends. Nonlinear regression models these curvy relationships. Think of how medicine dosage impacts recovery time. It improves results up to a point, but too much can be harmful. A simple nonlinear regression equation can look like y equal to a plus bx square plus epsilon, where y is dependent variable, x independent variable, a intercept, b slope, and epsilon is error, where curve describes how y changes more sharply or levels off as x increases. Relationship levels of a curve, not line. Once we know this relationship, we can use regression to predict, and that's where its real power begins. Regression is not limited to textbooks. It drives real business, economic, medical decisions every day. E-commerce company wants to understand how discount influence sales volume. Using regression, they discovered that for every 1% discount, sales increase by 2.3%. This insight helps pricing team forecast impact of promotions and optimize profit margin. Company uses regression to study how training hours impact employee productivity. Analysis shows that every additional hour of training improves performance by zero point 0.5 points. But beyond 20 hours, improvement slows down. That helps HR optimize training budget. Hospital uses regression to estimate patient recovery time. They find that age and dosage together explain 75% of the variation in recovery speed. This means model can predict how long similar patients might take to recover, improving treatment planning. Regression can do amazing things, but only if we play by few important rules. Let's explore key assumptions behind every good regression model. Regression models work best when few key assumptions are made. Linearity. Relationship between x and y should be linear. If it's curved, simple regression model won't fit well. Independence. Each observation should be independent. For instance, yesterday's sales shouldn't directly influence today's in dataset. Homoscedasticity. Variability in errors should be consistent across all levels of X. If error increases with X, your model might be biased. Normality. Residuals should follow normal distribution. When these assumptions are made, your model is trustworthy. When they are not, your predictions can be misleading. After validating assumptions, we can finally interpret results, the moment of truth. When you run regression in tools like Excel, Python, or Power BI, you will see summary table with several key metrics. Let's understand most important ones. First, coefficients. Coefficients show strength and direction of each variable's influence. Positive coefficient means as variable increases, so does the outcome. Negative one means opposite. Second, R squared. R squared tells you how much of variation in y your model explains. R square of zero point 0.8 means 80% of change in your dependent variable is explained by your predictors. Third, p-value. P-value tells you whether your findings are statistically significant. P-value less than 0.05 generally means your result is unlikely due to chance. Once you understand these results, regression becomes lens for smarter decision making. Regression analysis is backbone of data-driven decision making. It helps companies forecast demand, identify key drivers, and minimize risk. In e-commerce, it is used for price optimization, sales prediction, and recommendation system. In businesses, it guides budgeting, market analysis, and ROI forecasting. In healthcare, it improves treatment plans and patient outcomes. Power of regression lies in its simplicity, turning historical data into predictive insight. So far, we have focused on regression models that predict continuous outcomes like sales, revenue, or recovery time. But what if outcome is simple yes or no? Will customer buy or not? Will transaction be fraudulent? Or will patient test positive? That's where logistic regression comes in, a powerful tool for predicting probabilities and classifications. We will explore that in upcoming video, Logistic Regression Made Simple, where we will decode how to model binary outcomes using data. So, what have we learned until now? Let's recap. Here's what we covered in this video. Regression analysis helps uncover relationships between variables. It predicts outcomes and supports data driven decisions. Equation y equal to a plus b into x plus epsilon explains how one factor influences another. We explored its applications in e-commerce, business, and healthcare. And we learn how to interpret key metrics like R square and p values. Regression is not just about numbers, it is about patterns, predictions, and purpose. It helps transform data into direction. Next, we will explore hypothesis testing, method that tells us whether our insights are statistically valid. Then we will move on to correlation analysis, uncovering how variables relate before regression comes into play. Step by step, you will master foundation of data analytics. If you found this video helpful, don't forget to like, share and subscribe to Shital's Data Desk, where data meets clarity. Thanks for watching.